How to search for a chemical structure using SciFinder. So when first logging into SciFinder, it will automatically bring you to this research topics section, which basically acts like Google. And you can type in any word and see what comes up for journal articles or patent literature. For searching a chemical structure, you want to click on the one that says G, chemical structure, and then click on the click to edit to pull up the structure editor. This works a lot like ChemDraw, where you can click and drag to make a bond, click and drag again, or you can just auto click there and it will automatically establish. So let's say I want to search alpha-methylbenzylamine. So knowing that structure, I'll put this out and say I want the nitrogen here, which I can insert by clicking H or N on the keyboard. Hydrogens for H. If I wanted an oxygen, I could click O. Sulfur for an S for a sulfur, P for phosphorus, and L for chlorine, B for bromine, and F for fluorine. Now I want to insert the benzene ring, so I go down here and I click that benzene, and my cursor changes to be moving a benzene ring around. You also have a default cyclohexane, cyclopentadiene, cyclopentane, and this one allows you to draw anywhere from 3 to 15 sided rings by just typing in how many carbons it contains. Now, we want this exact structure, so we're going to hit exact search and hit OK. If you now click advanced search, you will get a whole bunch of other options. So we want a single component. We don't want this to have any ions or other components to the mixture. It's going to be included in references, and it should be commercially available. So by checking all of these, we demand that all 3 conditions be met. Now we hit search. This little test tube filling beaker, filling test tube pops up, and we get 16 different options. You can see that the first one is the racemic, second one is the S, and third is the R. Then we have some protonated, and we have some deuterated ones as well. These ones are N15 labeled, but these are the ones of interest. If we want to see what reactions it's used in, we can click this little green Erlenmeyer, and that'll bring up this box, and we can say we want to make this, or we want it to be a reactant, or a reagent, catalyst, solvent, or we just want to see a reaction that's used and all the reactions it's used in. Hitting this little orange Erlenmeyer right here lets us see the commercial sources. So anyone who sells it from the list that SciFinder has compiled. This little icon right here with the page pulls up references. So this one has been used in, this compound has been referenced in approximately 5,329 different references. We also have a whole bunch of options for analyzing it. So let's say we have elements and we want to make sure we don't have, we want to see which ones have been deuterated. We can click the D, it'll process, and it'll show us only the results that have deuterium in them. So going back, let's say we just want a substructure. So I want to see any alpha-methylbenzyl-amides. So working from this structure, we're going to make it an amide by clicking this hydrogen, making it a carbon, reestablishing that hydrogen because I shouldn't have deleted it to begin with, having it 2 come off there, double click that bond to make it a double bond. If you triple click or click again, it will make it a triple, and then it'll go back to a single. We wanted a double, so we can make the carbonyl. Then we actually want to lock these atoms. We don't want them to change, and we can lock this ring so that it'll only select like benzene rings. It will not show anything naphthalene or anything with substitutions coming off of it. When in doubt, and you really want to make sure you're not going to have anything substituted here, you can draw the other bonds and put in all your hydrogens, like so. So let's say I really want to make sure that this carbon has one hydrogen, and this is a methyl group. We can draw them all, and we can hit Substructure Search. So this will search for any compound it has in its database that has this structure in it. So hit OK. Again, it's remembered that we checked these, but this time we don't care if they're commercially available, because these we're looking at making. So we hit Search. We wait for the test tube and the beaker to stop filling one another. And there we go. So we can see the first thing we get a whopping 56,162 substances, which is too much to use the Analyse tool. Analyse functions, but we can go in and refine. So we have various different things we can refine with. So anything with an isotope we don't want, so we can click isotope containing and hit Exclude isotope containing substances and hit Refine. This will exclude anything that's carbon-13 labeled, deuterated, N15 labeled, and so forth. And you can see we've dropped from 56,000 to 55.9 thousand. Still too many to use the Analyse tool, so we can exclude all the metal-containing ones as well. And that's still too many. We're still at 55. We're only at 55.3, and we need it under 20,000 to use the Analyse tool. So we can go into the refined chemical structure and say, okay, well, maybe I just want things where this has a benzene ring of any substitution on it. Or even better, let's just find it can be any cycle. So if we hit X, we can get the shortcuts for variables. These also work with the keyboard keys. So hitting A, that atom will be any atom except hydrogen. Q for any atom except carbon or hydrogen. These four down here, you can't keyboard shortcut, but we're going to want any carbocycle. So any cyclical structure that's made of carbons. And we hit Close, and we hit OK, and we hit Refine. You can see it's processing as this working bar flashes across the screen. And now we only have cycles here. So it's got cyclopropyl, we've got benzene, we've got cyclobutane, so on and so forth. And now that we're under, we only have 8.6 thousand, we can use the substances, the Analyse tool. So let's say I only want things to have just these carbons. So we can see that we have some other elements in here. If we hit Show More, we can select all the elements we don't want. So we don't want fluorine, sulfur, chlorine, bromine, iodine, silicon, selenium, boron, or phosphorus, and we can hit Apply. And as this applies, it will show us any of the results that have those elements as part of them. We can then keep analysis. As it processes and processes and processes. And then we can hit Save. Save this answer set. So I'm just going to type this as hetero and hit OK. From here, we can remember that we don't want any of these that resulted in here. So we go back one step by clicking up here. So this goes back to where before you had selected the keep the elements, and you can go to Tools and Combine Answer Sets. From here, you can check box 1, and you can get the option to combine. So the two answer sets are merged, intersect. so only the answers that appear in both sets. Exclude option A, where anything in the current answer set that's not in header row, so that saved one shows up, or exclude the other way to where only answers that are in header row and not in the current answer set are shown up. So we want exclude option A. Combine. It takes a bit, but it removes all of them and brings us down to 2,611 results. Now, there are additional elements that we can insert besides just these. If you go to Atom, you will pull up the periodic table and you can insert whatever element you so choose. You can also use shorts for most functional groups. So here you see a CH, a CH2, methyl, methoxy, phosphoric acid, a nitrate, all a whole bunch of different options. Clicking this tool will allow you to say, I want a group substituted. So if you have a carbon and you put it here, you can then click this and say, I want this carbon to be either connected to this part of the ring, this part of the ring, this part of the ring, or so forth. And of course, Control-Z works as an undo. If you want to make a long alkyl chain, you can use this button. This is a lasso, so swing it around to select your molecules. The square version of the lasso, so you select a box instead of a freehand shape. R, so if you say, okay, this doesn't have to be a hydrogen, it could also be a carbon, so you can click, I could say hydrogen, I could say carbon. It could also be any of the shortcut functional groups they have, or any of the variables they have, and then you click and it turns into R1. This is an eraser tool, so boop, it's gone. Ta-dum. If you have polymers, you can use this function right here for repeating groups. This allows you to rotate or flip fragments, so things you've selected, and positive and negative charges could be here. These ones down here, these four, you generally won't use. And we don't want to save changes, so that'll revert it to the original structure. Now let's say we don't just want any carbocycle, we want a 5-membered ring. So we can click that here and note that the CB still stays, so we need to click the carbon and change that CB to a carbon and hit OK. Refine, and this will narrow down our results even further. You can continue to do this again and again until you get a manageable number of results. So you can see from that 2000, we went all the way down to 180. And all of these have some form of cyclopentane in their system. If you want to save, you can hit Save Up here. And if you want to get every reference for all of these, you can just hit the Get References up here. Or if you want to say, okay, I want a reference for this, I want the references for this one and this one, you can check them and get those references. By leaving them all unchecked or all checked, you'll get the references for all. You can do the same with Get Reactions and Get Commercial Sources. This concludes the video.